Hello and welcome everyone, Tiberius here, and as part of an exciting new series of videos, we're diving into the world of Burp Extension Development. That's right, I'm going to show you how to soup up your Burp Suite installation, even the free community edition, with custom Burp extensions written using the new Montoya API. Kickstarting this series, we'll set up our development environment and walk through making your very first Burp Suite extension. In the following videos, we'll add new features and explore what the Burp Extension API has to offer. Got a cool idea for an extension feature? Hit me up in the comments and I'll do my best to tackle the most popular requests in future videos. And hey, if you enjoy this content, please give the video a like and of course consider subscribing to the channel. As a web app pen tester, Burp Suite is my Swiss Army knife. It's an incredible tool, but sometimes it just falls short. For instance, I once encountered an API with a custom authentication method that involves signing each request, something Burp Suite cannot do natively. On another test, the web app used unique tokens to authenticate each request. Tokens were only valid for a single request and the response would contain the next token to use. On top of that, if the wrong token was sent, my session would be terminated. In both cases, Burp just couldn't be used to its full potential without lots of manual effort. That's where I had to get creative and build my own extensions. In the first example, my extension calculated the signature and added it to the requests automatically. In the second, it tracked the tokens when they were received and assigned them to the next request. These weren't super complex, but I've built more advanced extensions during my career, adding custom scanner checks and making it easier to copy requests into reports. Let's jump into setting up our development environment. We're using the Montoya API, which means our extensions will work on Burp 2022.9.5 and beyond. Unlike the legacy API that supported Jython, a Java implementation of Python, the Montoya API is all Java. If Java is new to you, consider checking out Codecademy's free Java course. I've put the link in the video description. Learning the language will make creating extensions a breeze. We're going to work in an integrated development environment, or IDE, which is a special piece of software that helps us write code. It can even create some basic code for us. While we build our extension, I'll also explain some of the general concepts we're using. Just remember, the better you know the programming language, the smoother it'll be to turn your ideas into code. Since Burp extensions can only be coded in Java 17 and below, we need to install the Java 17 development kit. On Kali, open the terminal and run these commands. First, we need to make sure our software repo sources are up to date, so we run sudo apt update. Next, we can install OpenJDK 17 using sudo apt install openjdk-17-jdk. Please note the -jdk at the end of the package name, which is important to include. We're using IntelliJ IDEA as our IDE, so go ahead and download it from the JetBrains website. We need to go to the download page, then other versions, and finally download the tar gzip. Once we extract that, we can cd into the extracted directory, then into bin, and finally run idea.sh. When IntelliJ opens, create a new project. Give it a name, like My First Extension. Choose Java as the language, Maven as the build system, and make sure it's using JDK 17. Finally, deselect the Add Sample Code option. Now let's get the Montoya API into our project. We can do this by adding the necessary dependencies to the pom.xml file. If we use this article on the Portsfigure website, we can see there are a number of ways to do this. Since we configured our project to use Maven, we just need to copy this XML and open the pom.xml file in our project. Our pom.xml file doesn't have a dependencies section, so we'll need to create it. IntelliJ should auto-complete it for us, and we can paste in the copied code. A tooltip may appear asking whether we want to load Maven changes. We can either click this, or click the Maven icon on the right, right-click our project name, and choose Reload Project. This will download the Montoya API library for us. Check external libraries to ensure it downloaded OK. Finally, we need to ensure our project creates a jar file when we compile our code. We'll use this jar to install or share our extension. Go to Project Structure in the hamburger menu, click on Artifacts, add a new jar artifact, and choose From Modules with Dependencies. Ensure you select Include in Project Build and OK all the dialogues. That's it, we're ready to write some code. In our project pane, go to Source, then Main, right-click on the Java folder and create a new Java class. Give it a name, for example, My First Extension. In this class, we need to import the Burp Extension interface and the Montoya API. Now, since this is going to be our main extension class, we need to implement the Burp Extension interface. Capitalization is very important in Java, so make sure you type exactly what I do. Don't worry if you see a red error line. IntelliJ can help us fix this. Right-click on the error, choose Show Context Actions, and let IntelliJ implement the required methods. Now we have an initialize method. The @override line tells the compiler that we're overriding the default implementation of this method. Public means other classes can use this method. Void means the method doesn't return anything. Initialize is the name of the method, and within parentheses we see that the method is passed an instance of the Montoya API via a variable called Montoya API. In Java, every variable we create must have a declared type. Let's rename this variable to simply API to avoid unnecessary confusion. This variable will be accessible to us inside the curly braces of the initialize method as an instance of the Montoya API we can interact with. Now let's set the name of our extension using the Montoya API. Go ahead and click inside the initialize method, and then reference the API variable. If we type a period, a little menu will pop up. This is IntelliJ showing us the things we can do with the Montoya API instance. We can pick what we want in this menu by using our cursor to click on it, or just hit enter on our keyboard. If the list is really long, we can just start typing, and IntelliJ will show us the things that match what we're typing. In our case, we're looking for the extension method. On the right, we are told what type is returned by the method. Extension returns an extension instance. Generally speaking, any capitalized type is a class, and a lowercase type is known as a primitive. We don't need to worry too much about what classes are right now, but the Codecademy course may help. For the purposes of this video, classes have their own defined methods which we can use, while primitives can be thought of as a raw data value such as an integer number. Let's go ahead and use the extension method in our code. Type a period again and you'll see the methods associated with the extension instance. We're going to use the setName method. You might notice it takes an argument called s, which is the string type. When we use the setName method in our code, IntelliJ will put our cursor inside the parentheses so we can enter this string. If we have some string of text stored in a variable, we can use that here. But if not, we can enter the string directly using double quotes. In Java, we use double quotes for strings and single quotes for single characters, unlike Python or PHP, where both can be used for strings. Let's name our extension MyFirstExtension. One last thing. You'll see that IntelliJ added a semicolon at the end of the line. In Java, every regular line of code needs one of these semicolons at the end. But conditional statements like if, else, for, and while don't need them because they have their own structures using curly braces. We could compile our extension now, but it doesn't really do anything other than set its own name. Let's add one more line of code to log a message when the extension first loads. On the next line, reference the API variable again and add a period. Then choose the logging method, which returns a logging object. Add another period, and choose the log2output method. Like the setName method, this also takes a string as an argument, which is the message we want to log. Save the file, and now let's build our extension. Click on Build in the hamburger menu and select Build Project. Note we could also press Ctrl and F9. To see the build output, click the hammer icon in the bottom left. The green checkmark tells us that the build finished with no issues. If we open the Out folder, then Artifacts and drill down, we'll find the jar file has indeed been compiled. While we're actively developing extensions, it makes more sense to load this file directly in Burp, since when we add features and recompile, we can simply reload it in Burp instead of needing to copy the newly compiled file somewhere. To load our extension in Burp, go to the Extensions tab, click Add in the Installed subtab, and select the jar file. By default, IntelliJ saves all projects to an Idea Projects folder in our home directory, and we can find the jar file there. Click Next to load the extension. Note that when it is added to the list of extensions, it has the name we gave it, and in the Output tab, our message has also been logged. Even if we close this window, we can choose the extension and select the Output tab to see our message again. To end this video, we're going to add one more feature to our extension. We'll then recompile it and load it back into Burp. Our new feature will let us tweak the requests that Burp sends and add a custom header. This is something Burp can do by default, but being able to modify requests is useful in many extensions. First, we need to import the HTTP handler. This gives us access to another interface. Ideally, we should create a separate Java class for this interface. However, to keep things simple, we will add it to our main class. Where we implemented the Burp Extension interface before, add a comma and then enter HTTP handler. IntelliJ will try to help us, but be wary that there are two HTTP handler interfaces. If you decide to use this help menu, make sure you choose the correct one, which in this case is the one which matches our import from earlier. Again, you'll see an error message because we haven't implemented the methods for the new interface yet. Let's get IntelliJ to do that for us. It'll add two new methods: handle HTTP request to be sent and handle HTTP response received. For our extension, we're only interested in modifying requests, so we can leave the handle HTTP response received method unchanged. In the handle HTTP request to be sent method, we can remove the return null line. Don't worry about the error message, it's just there because we do need to return something eventually. This method is passed an instance of the HTTP request to be sent class using a variable HTTP request to be sent. This represents the request we want to change. According to the method definition, we need to return a request to be sent action object, but we currently don't know what that is. So let's find out by consulting the API documentation. We can find it online at the link on the screen and in the video description. Here we see a number of available methods, but for our purpose we need a static one, which means we don't need an instance of the request to be sent action class to use it. Static methods can be called directly from the class type itself, and luckily both of them return a request to be sent action instance, which is what we want. Both methods are called continue with, however they take different numbers of arguments. We'll use the first one because we don't need annotations. It needs an instance of the HTTP request class, but we don't have one. If we click it, we see that this interface has a sub-interface of type HTTP request to be sent. What this means is that if we have an instance of the HTTP request to be sent class, by a bit of Java magic, we also have an instance of the HTTP request class. The instance can behave as both. If we go back to our code, we can see that we already have an instance of the HTTP request to be sent class, since it was passed to the handle HTTP request to be sent method. If we look back at the HTTP request documentation and scroll through the available methods, we come across a few with methods, which all return a copy of the HTTP request with some modification. It looks like the with added header method is what we need. There are two methods. One uses an HTTP header instance, but let's use the simpler one, which takes two strings, the first for the header name and the second for the header value. We can now tie everything together. Technically, we could do this in one line, but to make things slightly easier to understand, let's create a new variable for our modified HTTP request. HTTP request is colored red because we haven't imported it yet. To fix this, right-click, choose Show Context Actions, and choose Import Class. Be careful because there's a native HTTP request class in Java, but we want the burp one. Now we can use the HTTP request to be sent variable and the with added header method to add a header with a name and value. Remember, header names can't have spaces, so make sure it's valid. Now we can use our modified request in our return statement. First we type return, then a space, then we need to reference the request to be sent action class, and again use a period to see what methods we can access. The only two are the static ones we found earlier. We can use the first one since it just needs our HTTP request instance. We can then enter the request variable into the method, and we're done with this section. One last thing to do is register our HTTP handler with Burp. We do this inside the initialize method with a single line of code. When we get to the register HTTP handler method, we need to tell it where the HTTP handler instance is. Since we've created it within the same class, we can use the keyword this. Save and rebuild our project. Back in Burp, we could unload and then reload the extension, but there's a shortcut. If we hold down Control and click the checkbox, it does both automatically. Next, let's use our proxied browser to send a request to example.com. If we check the Proxy tab, you might be confused because the request isn't changed. That's because our modification happened after the proxy logged it. If you look in the Logger tab, you'll see that the request was indeed modified with the new header. This new header will be added to every request sent by Burp, not just the ones through the proxy. For example, requests sent through Repeater or Intruder will also have this header. If we only want the header added to proxied requests, there's a separate HTTP handler for that. Alternatively, we could have checked the source tool of the request before modifying it. I hope this has been a good introduction to the world of Burp Extension Development. With the help of IntelliJ and the API documentation, you can create basic extensions even if you're not proficient in Java. In my next video, we'll clean up our code and add more features. As I mentioned at the start of the video, if you have any requests for specific features, please let me know in the comments. I'll upload the code from this series to GitHub and provide all important links in the video description. That's all for now. If you enjoyed the video and found it informative, please consider giving it a like, subscribing to the channel, and I'll see you next time.